In this video, I will show you how to create a machine learning model and deploy it using FastAPI. We will be following these 6 steps. In step 1, we will create folder structure. We will have folders like data and model. In data, we will have our CSV file. In model, we will store our model object in pickle form. In main.py, we will write Flash application code. In train.py, we will train our machine learning model, and in requirement.txt, we will store our libraries or Python libraries. Step 2, we will install packages from this requirement.txt. In step 3, we will read CSV file from this folder data. In step 4, we will train our machine learning model, and we will write the code in train.py. This will be script to train the model. In step 5, we will deploy model using FastAPI. In main.py, we will write our FastAPI application code. And step 6 is to test model using FastAPI. How our project and folder structure will look like. So we will have our project name as iris_classification. Inside that, we will have 2 folders. One is data and the second one is model. In data, we will save our iris.csv file, which is going to be used to develop our machine learning model. In model, we will store our machine learning model as pickle object. In main.py, we will have FastAPI application code. In train.py, we will have our machine learning model training code. And in requirement.txt, we will have Python libraries that we are going to install. If you watch this video till the end, you don't have to go anywhere else to learn about model deployment using FastAPI, because we will be covering everything from scratch. So let's go to our PyCharm and start creating this project. Let's open PyCharm. In Windows, I will type PyCharm here. You can even use VS Code editor. It is not necessary that you have to use PyCharm only. Now you have to create a new project. So I will go here and click on this new project. After that, you have to give your location. My current location is desktop. You can select your location from here, and maybe you can give C or D drive, anyone. But for now, I'm going to keep it desktop. And here in Python project, here you see name. You have to give your name here. So I will write here iris_classification. And this will be our project folder name. Then you have to click on this create button. You don't have to do anything else. Just click on this create. And this will create a new project for us. It is also creating virtual environment automatically, so we don't even need to create any virtual environment here. Now I will just make it full screen, and here you can see it has created this project structure iris_classification, and this is the virtual environment it has created. We don't need this, and if you click here, you can just close these subfolders. Now, as I have said that we are going to create 2 folders, data and model. So let's create. Then you have to right click here and select new directory. And here you have to write directory name. First I will write data. Then let's create second directory. Again right click, new, and then directory name. The second directory name is model. So we have these 2 directory now. In data, we will have our CSV file, and in model, we will have our model.pickle object. Then we have to create Python files. First, I will create main.py. Right click, new, and then Python file. Select this one. Type main.py. You see we have this main.py. Now let's create train.py Python file, and then write train.py. This we will use to train our machine learning model. Press enter. And now one last file that we will create, requirements.txt, where we will define the packages that we want to install. Right click, new, and then you have to click here just file, because this is going to be a text file, not a Python file. And type here requirements.txt. So now we have our project, which is iris underscore classification, and we also have our folder structure. We have data, model, main.py, requirements.txt, and train.py. Now our folder data is empty, so we will copy CSV file into this folder. I'll go to desktop, and this is the project structure or folder iris underscore classification. I will open this, and inside this I have this folder data, and inside this I will paste iris.csv file. So this is the file I have pasted, and now let's go back to this iris classification, and let's go back to our PyCharm. And if I open this data, I can see iris.csv file is there. So we will be using this file or this data to train our machine learning model. Now let's first define the libraries that we are going to install in requirement.txt. So I will double click, and it is already open here. First I will install FastAPI, second scikit-learn, then third I have to write it like this, scikit-learn, then third pydantic. This will help us to give suggestions. Then uvicon. Uvicon is a server used by FastAPI to deploy our models. Then pandas, numpy, and joblib to read our pickle file. Now let's open terminal. On the left hand side you will see this option terminal. Now I'll write here pip install -r, then requirements.txt, and you have to remove this dot and backslash. Press enter. This will install all the libraries that we have in requirement.txt. You see that it has started downloading it. Let's wait. All the packages are installed. Now we will start training our model. I will open this train.py, and I will import all the libraries that we need. Import pandas as pd from sklearn.model selection. Import train test split from sklearn.ensemble. Import random forest classifier. We will be using this random forest classifier algorithm from sklearn.metrics. Import accuracy score, and then import joblib. Now let us read our CSV file. So I will write here load dataset. Data, I will create a variable data, and then from pandas pd.read underscore CSV, I will give the CSV file name which is stored in this directory data. So in double quotes I will write here data and then iris.csv. And then we can check this. I will print data.head, and I will run this. To run it, right click here and click run train, and here in the output you can see our data frame. So if I scroll on the left side, you will see that we have sepal length, sepal width, petal width, and species. These are our features, and species is our target variable. We have to predict the class of species, and there are 3 categories in this species class. We can check that. I will print it. So I'll write here print data, then species dot value underscore counts, and to run it, right click and click run train. So you see that in the output there are 3 categories: setosa, versicolor, and virginica, and 50 is the total number of samples in each of these categories. So we have these 3 categories, and we have to predict whether the flower belongs to which species. Now you see that this species column is in string, so we have this setosa, versicolor, and virginica. But you know that machine learning model only understand numbers, they don't understand string. So we will convert this string into numbers. So let's do that. Map species to numerical values. Now I will call our data and then species, and then I will call again our data and species. Then I will call the function map, and inside this I will create a dictionary, and in this dictionary I will write first category is setosa. You see here, this is the first category, setosa, and we will mark this as 0. Then the second category is versicolor, and then we will number it as 1. The last one is virginica, and we will number it as 2. And then we can again print this. So I will copy this from here and paste it here, and let me print it again. So I will run this, and now here in the output you see that earlier we had this string setosa, versicolor, and virginica, and now we have converted it into number 0, 1, and 2. So 0 is for setosa, 1 is for versicolor, and 2 is for virginica. Now we can use this target variable in our classification model. So now let's define our features and labels, that is our target variable. So I will write here define features and labels, that is x and y. X is our feature and y is our target variable. So in x we will have all the columns except the last one. So I will write here data, I will take all the column and drop last one. So last column is species, I will drop this, and then I have to give the axis. Axis is equal to 1 for columns. Now by default it is taking this as labels. Then I will define y, which is our target variable, data, and then we just want species. So I will write here species. This is our target variable. And now we will split this data set x and y into train, test. So x train, x test, y train, y test. I will write here split data into training and testing sets. First is x train, then x test, y train, and then y test. And then we will call this train test split. Inside this we will pass our x and y, and then test size is going to be, let's say, 0.2, and random state is equal to, let's say, 42. You can give any number here. This is just for the randomness, so that you will get the same sample every time you run this script. Now let's train our model. So we will create an object of our random forest class. I will write here initialize and train the model. So I will make an object model, and then I will call this random forest class classifier, and then I am going to fit this model on xtrain and ytrain. So we have fit this model on our training set. Now we want to make prediction on our test data, that is x test. So let's predict it, predict. So I will make one variable y_pred where I will save the prediction, and then I will call this model. From this I will call the method predict, and then I want to make prediction on our testing data set, that is x_test. And then I can also check this prediction. So I will write a print y_pred. So let me execute this script to show you our predictions. So you see, these are the prediction. It says that the flower belongs to 1, then the second belongs to 0. 1 means, what do you mean by 1? So you see here, 1 means versicolor. So the first flower belongs to versicolor, second flower belongs to setosa, third belongs to versicolor, then fourth belongs to versicolor, and so on. So these are our predicted values. Now we will do the evaluation to check the accuracy of this model, and then we will save this model as our pickle file. So let's do the model evaluation. I will make a variable accuracy, and to calculate accuracy I will call this function accuracy score, and inside this I will pass our y test to compare it with ypred, and then let's print this accuracy, print accuracy, and let's run this again to check the accuracy. It says 1.0, that means our model is 100% correct. So this accuracy is really too much, it is 100% correct. Now let's save this model as our pickle file. For this I will call joblib dump, and inside this I will give our model, which is nothing but this model that we have created here. So this model I am passing here, and then I have to give location where I want to store it. So I want to store this in this folder model. So I will write here model. Inside this I want to save this model as a name model.pkl or pickle. So right now you see that it is empty, and once I run the script you will see we will have model.pickle object stored in this. So I will just run this, and now you see that if I expand this, so we have this model.pickle stored in this folder. So what we have done, we have trained our model. Now the last part is to create our FastAPI application. So now we will open our main.py. Let me close this requirement.txt. I will also close this train.py, and I will just open this our main.py. So let's first import the libraries that we need. From FastAPI, import FastAPI. Then from Pydantic, import base model, import job_lead, import numpy as np. So we have imported all the libraries that we need here, and I will also tell you why we are using this library. So Pydantic is used for data validation and settings management with Python type annotations. And for base models, so in the FastAPI application, base model is used to define and validate the request body that you will see as we move step by step. So now we will load our train model that we have saved here, model.pkl. So I will write here load the train model. I will make a variable model and then I will call job_lead. From this I will call load, and then I have to give the path. So the path is model, this is the directory. Inside this model.pkl. So here I am loading our model, and then next we will create an instance of FastAPI. Create instance of FastAPI. So I will write here app and then FastAPI. So we have created this instance. Now we will define the request body for our input data, that is the input features that we will send, and based on that we will get our predicted value. So let's define that. Define the request body for input data or our features, or you can say independent variables. So I will define a class predict request, and this will take base model that we have imported, and inside this we don't have to do anything. It's very straightforward. What are our independent variables? So our independent variables are sepal length, sepal width, petal length and petal width. So let's write down that. I will write here sepal underscore length, and then we also define their data type. So it is going to be float because it is taking inputs in digits. Then sepal width data type is going to be float. So spelling, there is a mistake, I will write a width. Then we have petal length, the data type is going to be again float. Petal underscore width, the data type is again going to be float. So we have defined our this base model or our class predict request. Now we will define the prediction endpoint, and that's it. Then we can deploy this using FastAPI. So let's define the prediction endpoint or the URL where it will go and hit. So I will write here define the prediction endpoint, and then I will call app. App is nothing but the object of FastAPI that we have here. So I will write here app, and then we will use the method post, and then I will define the URL here. So when I will call this, it will go to this page predict, and inside this I will define this predict method. So I will write here define function name is predict, and inside this our parameter is going to be request, and this request will take this class predict request. So I will call this predict request class here, And then what we have to do, we have to pass these independent variables or these features as arrays and store that in a variable. So I will define a variable data here, and then I will call np.array, and inside this I will make a list, and inside this I will create a sublist here, and then I will call request. So we have this request here that we have defined, and from this I will call all of these variables dot sepal length, and then request dot sepal width, then request dot petal length, and then request dot petal width. So I have called all of these features from this request, and once I have this data or these features, then I will do the prediction and save it in a variable prediction. So I will write here prediction here, and then I will call, to make prediction I will call our model, which is stored in this model object. If I scroll up, you see here, okay, I have made a spelling mistake. I have to write here, no, this is right, model. Okay, so I have this model here. To make prediction I will call this model, and from this I will call the method predict, and then I will pass our data, this data where we have our features, and we will save the prediction in this prediction variable, and then we will map this, because what we will get in prediction, we will get 0, 1 and 2, and we want to map it with the original one, that is 0 is for Setosa, 1 is for versicolor, and 2 is for Virginica. So I will create species underscore map, a new object, where I will map this. 0 is for Setosa, then 1 is for versicolor, and then 2 is for Virginica. So once we get the prediction as 0, 1 and 2, we will convert them into this original Setosa, versicolor and Virginica string format, and then we will return this, we will return a dictionary prediction. What we will return? We will return this species map, and then we will convert this into integer of prediction, and then we will take the values at index 0. So now when we will call this will start the server, and you will be able to access your API. So before that, I'll just add one more thing so that it looks nice when we go to the URL. I will write here app.get, and this is the URL where we will go, and I will define a function, define read underscore root, and then this will return a message, and the message will be nothing but welcome to the iris classification API. That's it. So we have defined our FastAPI application. Now we will run this. When we will go to the page, we will see this welcome to the iris classification API, and then there we can test this also. So let me run this. I hope we will not get any error. Click on this run main. We did not get any error. So now let's run this server. Let's go to this terminal here, and here you have to type uvcon main app, and you can pass this parameter reload as well. Let's run it. Now it says that the app is started and you have to go to this port 8000. Let's click on this. So this will open a browser, and here you see welcome to the iris classification API. So this is in JSON format, and if you click on this raw data, you will see here welcome to the iris classification API that we have defined here in this get. So, and if you click on this headers, you will see this response object, and this is the JSON object welcome to the iris classification API. Now to test it, you can just put a slash here and then write docs. So you will come on this FastAPI. This is a Swagger documentation. So here you can test your model. So now you see here we have this independent variables. So let me open this CSV file and we will do the testing. Now let's go back to our UI, and if you click on this predict, so you see that these are the independent variables. It takes sepal length, sepal width, petal length, petal width, and once you give the value, you will get the prediction here, and then you can click on this get here. So you see the code 200, that is successful response here. And now we will test it. I will click here, try it out. And now you have to give the values here to make prediction. Now we are testing it. So let's see, sepal length, let's say we will take this 10th row number. We should get the output as setosa. So first I will write 4.4 for sepal length. I will write here 4.4. For sepal width I will write 2.9. So you have to write here 2.9. Then for petal length it is 1.4. 1.4. And then last we have petal width 0.2. So I will write here 0.2. And to test it, you have to click on this execute. We'll click here. And now let's see the output. So you see the response body prediction, and the prediction it is setosa. So we got a correct prediction here because this also belongs to setosa class. Let's try out one more or two. So let's try for this versicolor, row number 52. So let's change the value now. For sepal length we will give 7. I will write here 7. For then the next value is 3.2, 4.7, 3.2. Then third one is 4.7, and the last one is 1.4, which is petal width 1.4. Now let's execute it to check the prediction. So the prediction is versicolor, and if you see here, so we got the correct prediction here, versicolor. You can also click on this reset, and then all the values will be reset to 0. And you can try it again. So you see that how easy it is to deploy your model using FastAPI, and you can also test it. You don't need to use Postman, or you don't have to write any Python script. You can just pass your values here and test it. You can even go down and explore this, what all options here you will see. So you have some HTTP validation error, predict request validation error. So if you get any error, you will see those error here as well. I hope you enjoyed this video. If you like my video, you can subscribe to my channel. Thank you for watching.